By the time you finish listening to this deep dive today, your brain will actually be infinitesimally smaller than when you started.
Which is, honestly, a slightly terrifying thought to kick things off with.
Right, it is. But, I mean, to all of you listening, I know exactly why you're here. You're curious. You want the critical insights, the really deep knowledge.
And you want it without having to, wade through a mountain of jargon or feel completely overwhelmed by information overload.
Exactly. You want to understand what is actually happening inside your own head, and more importantly, you want to know how to protect it. So, welcome. Our mission today is laser-focused.
Very focused. We are unpacking a fascinating new study detailed in a brief but just incredibly powerful source text we have our hands on. It's titled Napping for Neural Longevity.
And this text, it's short, but it carries massive implications for our daily routines.
Oh, absolutely. It is going to fundamentally challenge everything modern hustle culture has taught us about rest.
Right, because there's this huge stigma around napping.
Yeah, this pervasive societal idea that daytime sleep is just, pure laziness or a lack of drive. And we're going to completely dismantle that based on pure neuroanatomy.
I love that.
We are shifting that perspective to see napping not as a luxury, but as a vital, non-negotiable tool for long-term neural defense.
Because the core focus here is this truly surprising biological relationship between daytime sleep, the actual physical volume of our aging brains, and cognitive disease prevention.
Yeah, the physical size of the organ.
But before we get to the solution, I feel like we really have to look the problem right in the eye, right? We have to understand the biological reality that this text outlines right out of the gate.
Yeah, the text definitely doesn't sugarcoat the biological data. If we're going to understand the intervention, we have to first understand the structural degradation that happens to the human brain over time.
Okay, let's unpack this. Because the source explicitly states a stark biological fact. Quote, our brains get smaller as we get older.
Right.
Unquote. Reading that sentence for the first time gave me a genuine pause. I mean, we know enough about biology to understand that our bodies change, our cellular regeneration slows down.
Right. Your skin wrinkles, your joints ache.
Exactly. But the idea of our actual control center physically losing mass is just wild to me.
It's a lot to wrap your head around, literally.
How should we visualize this?
Yeah.
Are we talking about the brain just like dehydrating, like a grape slowly turning into a raisin over time, or like a sponge drying up and contracting? What is physically happening when the text says it gets smaller?
But what's fascinating here is that the researchers don't present this shrinkage as some rare disease or an anomaly, that only happens to a few unlucky people with a specific genetic marker.
Okay.
They present it as the universal baseline. It is the default state of human aging.
So everyone listening to this has happened to them.
Yes. Starting roughly in our late 30s and then really accelerating as we hit our 60s, the brain experiences a widespread decrease in overall volume. We are talking about measurable reductions in cortical thickness and gray matter volume.
Cortical thickness. So the outer layer of the brain, the cortex, is literally thinning out.
Precisely. And the gray matter, which contains most of the brain's neuronal cell bodies.
The actual processing centers.
Exactly. The processing centers, they lose density. And it isn't just water evaporating, like your great analogy. It's a combination of factors. Neurons themselves can shrink.
Wow.
And the intricate branches connecting them, which are called dendrites, they begin to retract and become less complex.
So the connections are actually pulling back.
Yeah, and there's a loss of the protective myelin sheath that wraps around the nerve fibers. So the actual physical real estate of your neural network is contracting.
But wait, how fast does this actually happen? Because if you just picture your brain slowly deflating inside your skull every single day, it sounds like a catastrophic event.
Well, it's a gradual, insidious process. Researchers measure this in cubic centimeters using advanced MRI scans. Over a decade, a healthy adult might lose a few percentage points of their total brain volume.
A few percentage points over 10 years. That doesn't sound like a lot at first.
It doesn't, but those percentage points are critical. The researchers are starting from this premise, this baseline of structural atrophy, not to scare us, but to establish the baseline they are trying to combat.
Right.
They are setting up the control group. The baseline human condition is volume loss.
And in the brain, volume matters. I mean, it's not just about the size of the organ. The physical space your brain occupies, the density of those neuronal connections, that's directly tied to how it functions, right?
Absolutely. The structural capacity of the brain dictates its processing capability. Think of it like a dense, thriving forest.
Sure.
If the trees start losing their branches and the root systems pull back, the overall footprint of the forest might look similar from a distance, but the internal ecosystem is far less robust.
So it can't support as much life.
Exactly, or, process as much information. When the text simply says our brains get smaller, it's pointing to this natural, daunting physiological process where the density of that forest is thinning out.
Which brings us to the most crucial question for you, the listener. If this shrinkage is the inevitable default biological reality, what on earth can we do about it?
Right, are we just supposed to accept it?
Yeah, are we just supposed to accept the structural laws?
Yeah.
According to the new study we're diving into, the answer is a resounding no.
No, not at all.
The researchers found that this brain shrinkage does not happen as fast in people who regularly take what they specifically call short sleeps during the day.
And that is the core finding. They have essentially identified a behavioral brake pedal on the neurological shrinking process.
A brake pedal. I like that.
And they backed it up with significant physiological measurements, comparing the MRI scans of regular nappers versus non-nappers over time.
But here's where it gets really interesting, because I need to push back on the specific wording the source uses here. Why does the text specifically say short sleeps?
That's a great catch.
If sleep is the protective mechanism, why doesn't it just tell us to sleep as much as possible? Why not take a 4-hour slumber every afternoon? It feels incredibly specific to highlight the brevity of the sleep.
It is very specific.
It makes me think about my smartphone. If my phone starts running terribly slow because I have 80 apps open and the processor is overheating,
We've all been there.
right, I don't leave it plugged in and shut down for 3 days. I do a quick reboot, I clear the RAM. It's a short, intentional, mechanical reset to restore function. Is that what we are talking about here with a short sleep versus just a massive daytime crash?
This raises an important question, and your smartphone RAM analogy is actually a brilliant way to visualize the mechanism at play here. The wording in the source is highly deliberate.
Okay.
Short sleeps implies a completely distinct physiological mechanism from deep, prolonged nighttime style sleep. If you are sleeping for 4 hours in the middle of the day, you are likely dealing with a massive sleep debt.
Right, or chronic fatigue.
Exactly, or a severe disruption to your circadian rhythm. That is indicative of a system failure, not a system optimization.
Yeah, a 4-hour nap usually means you wake up feeling worse, groggy, completely disoriented. That doesn't feel like neural defense.
No, not at all. That grogginess is called sleep inertia, which happens when you wake up in the middle of a deep, slow-wave sleep cycle.
Oh, I hate that feeling.
It's the worst. But a short sleep, typically defined in these types of neurological studies as anywhere from 15 to 30 minutes, acts exactly like that quick computational reboot you mentioned.
Okay, so 15 to 30 minutes.
Right. You are not trying to enter the deepest phases of REM sleep. You are allowing the brain to enter a lighter stage of restorative rest.
But I'm still hung up on the how.
The mechanism.
Yeah, the mechanism. How does just closing my eyes and losing consciousness for 20 minutes actually physically stop tissue loss? That sounds almost too good to be true. I understand resting my eyes makes me feel better, but how does it preserve brain mass?
It comes down to neurochemistry and fluid dynamics. When you are awake, your brain is incredibly metabolically active.
That's working hard.
Very hard. It is burning through energy and, as a result, producing metabolic byproducts, essentially cellular waste.
Just from thinking and being awake.
Exactly, just from existing. And one of the most well-known of these is a protein called amyloid beta. As these toxins build up during your waking hours, they cause stress on the neurons.
So the longer I awake, the more polluted the fluid in my brain becomes.
In a simplified sense, yes. Now, scientists have discovered something called the glymphatic system, which is essentially the brain's specialized plumbing and waste clearance network.
The brain has its own plumbing.
It does, and this system is highly active when we sleep. Cerebrospinal fluid actually washes through the brain tissue, clearing out those neurotoxins.
Wait, so a short sleep literally triggers a biological wash cycle.
It initiates that clearance process, yes. Even a brief period of sleep allows the brain to downregulate its active processing and ramp up its maintenance protocols.
That is wild.
It's amazing. It clears out some of the accumulated metabolic waste that would otherwise stress the neurons and contribute to their degradation over time.
So it's washing away the toxins that cause the shrinkage.
Exactly. And furthermore, taking a short sleep actively reduces the levels of cortisol, the primary stress hormone in your bloodstream.
Oh, cortisol. We hear about that all the time.
Right. And chronic elevated cortisol is highly toxic to the brain, specifically to regions like the hippocampus, which is crucial for memory. High cortisol physically damages neurons and accelerates that shrinkage.
Wow. So by taking a 20-minute nap, you are simultaneously triggering a waste clearance system and shutting off the valve on toxic stress hormone.
You're hitting it from both sides.
That directly explains the preservation of the tissue. You are stopping the biological environment from becoming hostile to your own brain cells.
Exactly. You are mitigating the toxic load that accelerates the baseline atrophy. It's not about entering a state of hibernation to avoid aging. It's about introducing a brief biological reset into the waking hours to manage the cumulative stress on the neural architecture.
And the text also uses another very specific word alongside short sleeps. It says, quote, people who regularly take short sleeps.
Yes, that is the operative word, regularity.
So it's a habit.
It implies a habit, a daily maintenance routine. The study links the slower rate of shrinkage to the consistent routine application of these short sleeps over years. You cannot just take one nap on a Sunday and expect to preserve your brain volume for the decade.
It's the difference between brushing your teeth every single day to prevent plaque buildup versus going to the dentist once a year to get a massive cavity drilled.
A perfect parallel.
It is a daily maintenance protocol.
Exactly. The neurological studies looking at these MRI scans show that the people who maintain this habit consistently over time are the ones who show the statistically significant preservation of gray matter and cortical thickness.
So they're proving it with the scans.
Yes, they are essentially lowering the daily wear and tear on the organ.
You know, that structural distinction completely removes the guilt factor for me.
How so?
Because, let's be entirely honest, in our modern society, telling someone you are going to take a nap in the middle of a Tuesday is practically viewed as a moral failing.
Oh, without a doubt.
You're supposed to drink another espresso, push through the afternoon slump, answer 50 more emails, and just grind it out. If you step away to sleep, you are quote-unquote wasting time.
We have culturally categorized it as a luxury at best and a sign of weakness or poor time management at worst.
But if we look strictly at the empirical data in this source material, this study is saying the exact opposite. By taking that short sleep, you aren't being lazy. You are actively performing essential maintenance on your most critical organ.
Right.
You are putting a physiological halt to the natural shrinking of your brain mass.
You are actively resisting the biological default of aging. When the researchers report that the shrinkage, doesn't happen as fast, they are pointing to a visible, measurable difference in the physical trajectory of the brain.
It's visible on the MRI.
The MRI data confirms it. People who regularly take short daytime sleeps are literally holding on to more cubic centimeters of their brain mass over time compared to the control group of non-nappers.
Which leads us to the ultimate highest stakes part of this deep dive. Because knowing that naps preserve brain volume is great trivia. It is a fascinating biological mechanism.
Sure.
But why does the physical size of the brain actually matter to you, the person listening to this right now? Why should you genuinely care about your gray matter volume?
Because brain mass isn't just cosmetic. It isn't just about having a mathematically larger brain. It is entirely functional.
Right. And the source text brings down the hammer in its final, most impactful sentence. It says, quote, researchers suggest these naps might reduce the risk of developing conditions like Alzheimer's in later life.
And that is the defining insight of the entire study. That is why this research matters.
So what does this all mean? I mean, we have to drastically reconsider what we are doing every afternoon. Should we stop viewing the afternoon nap as a guilty pleasure we hide from our coworkers?
I think we have to.
It sounds to me like we need to start viewing it as a highly specific, daily, preventative medical treatment, like taking a targeted multivitamin for neural longevity.
If we connect this to the bigger picture, the implications for public health are staggering. We invest billions of dollars globally into researching pharmaceuticals, incredibly complex treatments, and advanced molecular therapies to combat cognitive decline.
Right, fighting conditions like Alzheimer's disease.
And we absolutely must continue that research. But here we have neuroscientists pointing to a behavioral intervention, a free, highly accessible, entirely natural habit that serves as a physiological shield.
A shield that specifically protects the structural integrity of your mind. But I want to ask, how does having more brain volume actually prevent Alzheimer's? I want to make sure we don't just gloss over that connection. Does the nap stop the disease itself?
That is a critical distinction to make. The current understanding isn't necessarily that a nap guarantees you will never develop the underlying pathology of Alzheimer's.
Okay, so it's not a magical cure.
No. Alzheimer's is characterized by the severe buildup of those amyloid beta plaques we discussed earlier, along with tau tangles, which aggressively destroy brain tissue and cause severe cognitive decline.
So the disease itself causes rapid brain shrinkage.
Yes, but this brings in the concept of cognitive reserve.
Cognitive reserve, what is that?
Well, if you enter your later years with a larger, denser, more structurally sound brain because you have spent decades engaging in protective habits like regular short sleeps, you have a much larger buffer against that decline.
Okay, I think I understand. If my brain is like a massive, highly connected highway system, and a disease like Alzheimer's comes in and starts shutting down roads, I'm going to be fine for a lot longer if I started with 10 lanes instead of just 2.
That is a phenomenal way to conceptualize cognitive reserve. Yes, by slowing down the baseline shrinkage of the brain throughout your 30s, 40s, and 50s, you are keeping more of those neural highways open and functioning.
Making a wider highway.
Exactly. You are maintaining a crucial structural buffer. So even if neurodegeneration begins, your brain has the physical mass and the alternate neural pathways to compensate for the damage for a much longer period of time.
Wow.
You delay the onset of the devastating clinical symptoms.
Yeah.
You are keeping more of the physical network that makes you intact for longer.
That is incredibly empowering.
Yeah.
We so often feel entirely helpless when we think about aging or the terrifying prospect of conditions like Alzheimer's.
It's very scary.
It feels like we're just waiting to see how the genetic lottery plays out, or we're entirely at the mercy of the cruel passage of time. But this study is saying, hey, wait a minute. You have a potent, biologically proven tool at your disposal.
Right in your own daily routine.
Right now.
Today.
You can lie down, close your eyes for 20 minutes, trigger your brain's lymphatic clearance system, lower your neurotoxic cortisol levels, and actively alter your long-term cognitive trajectory.
It completely democratizes neural defense. You don't need a multi-million-dollar medical intervention or an unpronounceable prescription for a short daytime sleep.
You just need a couch.
Yeah, you just need the willingness to prioritize your own biology. And perhaps the courage to push back against a workplace culture that demands you stay constantly awake, constantly stressed, and constantly producing at the expense of your neural health.
And it all ties back to that mechanical reality we mapped out. You are giving the processor its reboot. You are letting the cerebrospinal fluid run its wash cycle. You are systematically maintaining the structural capacity of the brain to function optimally.
When you lose less volume, you maintain more processing capability. It is a profound reframing of what it means to rest. Rest is not the absence of action.
Right.
It is a highly active, physiologically necessary state of preservation.
We started this deep dive with a very direct, somewhat alarming piece of text about the brain shrinking, but the scientific journey it takes us on is huge. So let's quickly distill the core takeaways for everyone listening so you can take these specific parameters with you into your week.
Yeah, it breaks down into a clear, empirically backed 3-step progression.
Right. Step 1, the uncomfortable baseline reality. Our brains naturally lose volume, gray matter, and cortical thickness as we get older. It's the default physiological state.
Unavoidable, but manageable.
Exactly. Step 2, the surprising, actionable antidote. A new study utilizing MRI tracking shows that regular short daytime sleeps, ideally in that 15 to 30-minute window to avoid deep sleep inertia, actively trigger maintenance protocols that slow this shrinkage down.
The daily reboot.
And step 3, the ultimate stakes. By maintaining a larger brain volume over decades, you build a massive cognitive reserve, potentially reducing the clinical risk of developing severe cognitive conditions like Alzheimer's later in life.
It is a brilliant scientific arc, from identifying the physiological problem to proving the behavioral intervention to fundamentally altering the lifelong cognitive outcome.
It absolutely is. And it leaves me thinking about how we actually apply this data to the real world. Because knowing the science is only half the battle, implementing it is the real challenge.
Well, I want to leave you, the listener, with a final thought to mull over on that front. Because if we take this neuroscientific data seriously, it doesn't just change our personal habits. It challenges the very fabric of how we organize our society.
Oh, definitely.
If science is now empirically proving that regular short daytime sleeps are not a luxury, but a vital neurological shield against brain atrophy and devastating conditions like Alzheimer's, How might this completely upend the traditional 9 to 5 workday?
Oh, man. There's a massive paradigm shift to consider.
Will we eventually see a near future where forward-thinking workplaces actively mandate nap times? Not as a quirky Silicon Valley perk with beanbag chairs to attract young talent, but as a basic, non-negotiable health and safety requirement for long-term cognitive protection.
Like an OSHA regulation for your brain.
Precisely. If depriving people of rest actively accelerates brain shrinkage and increases the risk of Alzheimer's, isn't it technically an occupational health hazard to force employees to stay awake and stress for 8 straight hours?
That is a brilliant provocation. Imagine human resources actually mandating a 20-minute nap for neural compliance, the same way they mandate ergonomic chairs or screen breaks.
It could happen.
I love that vision of the future. And it brings us right back to the empowerment this study offers. We don't have to just sit there and passively accept the biological baseline. We can actively engage our brain's defense systems.
We have the tools.
We really do. Thank you so much for joining us on this deep dive. Keep questioning the world around you. Keep looking for those small habits that have massive biological impacts. And seriously, go find a quiet spot and take a nap. We'll catch you next time.